Here's question 2 part C. As always with these mechanics questions, a good large diagram is essential. You can see what we've got here is the weight of the ladder here, the weight of the man here, the frictional force here, which in part B we've just worked out to be 392. There's a reaction between the ladder and the floor there, I've called that R1, and there's a reaction between the ladder and the wall there, I've called that R2. We need to find out the distance from A to C, that's this distance here, and this is a moments question, so we need to resolve these forces perpendicular to the ladder. We'll take moments about A here, so we can ignore these forces, R1 and 392, so we need to resolve the forces perpendicular to the ladder, and then take moments. So when we resolve the forces, we end up with the component of weight perpendicular to the ladder here, the component of the man perpendicular to the ladder here, and the component of the reaction perpendicular to the ladder there. So because this angle here is 60, that angle there is 30, that angle there is 60. So when we resolve the weight through 60 degrees, we get 20g cos 60. And the same thing here for the man, that's going to be 80g cos 60. Because the angle here is 60, that angle there is also 60, and this angle here is 30. So the component of R2 perpendicular to the ladder, I'm going to write it over here, is R2 cos 30. We're resolving through that 30 degrees, so it's cosine. We resolve through 60 degrees there, so it's cosine. It's always the cosine of the angle through which you're resolving. So that's a bit of a mess. Let's draw another diagram to show these forces. Do that on the next slide. So here I've just shown the three forces that are perpendicular to the ladder. We're going to take moments, so we need to find the distances. The whole ladder is 4 meters long. So if we start there at 0, that's 2, let's call that x, and that's 4. So this is the point A, so let's take moments about A. The anti-clockwise moments, that's going this way round, that's this force and this force. So the anti-clockwise moments must equal the clockwise moments. So what we get is 20g cos 60 times 2 plus 80g cos 60 times x must equal R1. Now R1 is the same as the frictional force, and we've worked out the frictional force to be 392. So it's 392 cos 30 times 4. Now personally I don't like writing all these convoluted expressions out all the time. Let's just work them out. 20g cos 60 times 2, that's 196. 80g cos 60 is 392 by coincidence, so 392x, and 392 cos 30 times 4 is 1357.9278. So from that x works out to be 2.96.